Now I want to provide an example, and for that, I'm going to set B to be the set of vectors 1, 1, comma, negative 1, 1. We see that B is a basis for R2. And more than that, is an orthogonal basis. And that's very simple to check. All that we have to do is to calculate the dot product between different pairs of elements from B. Well, there's only one pair, this pair. C, note that 1, 1 transpose times negative 1, 1 is equal to 1 times negative 1 plus 1 times 1, which is 0. So the vectors 1, 1, negative 1, 1 are orthogonal. So B is an orthogonal basis. However, B is not an orthonormal basis. And why is that? Well, fairly simple. Take, for example, this element, which is a member of B, and note that the norm of this vector is equal to the square root of 1 squared plus 1 squared, which is equal to the square root of 2, which is clearly different from 1. Now, the question is, can we transform an orthogonal basis into an orthonormal basis? And the answer is yes. And what is the process? Well, fairly simple. Take every element of the original basis and multiply it by the reciprocal of its norm. That way, we normalize each of those vectors and at the end obtain an orthonormal basis. So take B tilde, which is the following set: 1 over the root of 2 times 1, 1. So make the association between these two. 1 over the root of 2 times negative 1, 1. Well, the norm of this vector is the square root of 2. So I'm just repeating the process, multiplying by the reciprocal. Then B is an orthonormal basis